we have a 4 by 4 matrix, and we want to know what is the determinant of this matrix. So should you use the row expansion or the column expansion? The question you need to ask is, which column or row has the highest number of zeros? So obviously, the third column has the highest number of zeros. So you're going to select the column expansion. The third column expansion is going to be your answer. So let's see. Remember the formula, the determinant of A is equal to, here you have the sum, Aij, Cij, and I starts from 1 and it stops at 4. And here your J is equal to 3, because it's the third column expansion. So let's see. This guy is equal to A13, C13, plus A23, C23, plus A3 and 3, the entry on the third row and third column, times C3 and 3, plus A4, 3, C4 and 3. Take a look. A1 and 3. The entry on the first row and third column. First row and third column, which is 3. 3 times C1 and 3, plus the entry on the second row and the third column, 0, C23. Then you have 0, C33, plus 0, C43. So take a look at this. This is 0 times a number, 0. 0 times another number, 0 times another number. So this is just basically 0. What you need to do, you just need to find the multiplication between 3 and C13. So what is C13? First of all, you're eliminating this. C1 and 3 gives you this 3 by 3 matrix. This is C1 and 3. You're basically finding the determinant of this 3 by 3 matrix. Negative 1, 0, 3, 1, 2, 4, 2, 3, negative 2. Well, you can again do the exact same process, expanded with respect to one of the rows or one of the columns. So you can take a look at this. Here, your first column has the highest number of 0. First column expansion. Again, it doesn't matter which row or column you're using. In previous example I showed you, you get the exact same result. Here, since I have 0 here, I'm going to use the first column expansion because we have 0. That's the only reason that I'm using the first column expansion. So by using the formula, you have the sum of AI1, Ci1, and I starts from 1 and goes to 3 because you have a 3 by 3 matrix, which is A1 and 1, C1 and 1, A2 and 1, C2 and 1, plus A3 and 1, C3 and 1. And as you saw, this guy is just 0. So since this is 0, this becomes 0. So you have negative 1, C1 and 1, plus 0, C2 and 1, plus 3, C3 and 1. Now we need to find these C values. Cij is equal to negative 1 power I plus j, the determinant of the matrix left Mij. So this is 0. I only need C1 and 1, which becomes negative 1 to power 2, and I'm eliminating the first row and first column. So I'm left with this little matrix, 2, 3, 4, negative 2. C1 and 1 becomes 1 times negative 4 minus 12, or negative 16. So far I have negative 1 times negative 16 plus 3 times now C3 and 1. C3 and 1 is -1 to power 4 times the third row and first column. So here you have the third row, C3. 3 represents the row and 1 represents the column. So you're left with 1, 2, 2, 3, which is 1 times 3 minus 4 or -1. So this determinant is equal to 16 minus 3 or 13. Are we done yet? No, we have to go back to this guy here. This is 3 times 13 or 39. This is the answer. So the determinant of this 4 by 4 matrix is 39.